Some commercially important alcohols. Methanol. Methanol, also called methyl alcohol, was originally produced by the destructive distillation of wood chips in the absence of air. This source led to the name wood alcohol. Today, most of the methanol is synthesized by a catalytic reaction of carbon monoxide with hydrogen. This reaction uses high temperatures and pressures. Properties. It is a colorless, inflammable liquid. Miscible with water in all proportions. It is poisonous in nature. When consumed, causes blindness and even death. Uses. As a solvent for paints, varnishes and celluloid, for denaturing industrial alcohol, that is to make it unfit for human consumption, as an antifreeze in automobile radiators. Some commercially important alcohols. Ethanol. Ethanol is obtained commercially by fermentation of molasses, which contains sucrose. The sugar in molasses is converted into glucose and fructose by the action of an enzyme, that is invertase. Now, the produced glucose and fructose undergo fermentation in the presence of enzyme zymase and produce ethanol and release carbon dioxide. Properties. Ethanol is a colorless, volatile liquid with pleasing smell and burning taste, miscible with water in all proportions. Uses. As an antiseptic in the form of rectified spirit, as an antifreeze in the radiator of automobiles, in spirit lamps, stoves, thermometers and spirit level. Ethers. Preparation of ethers. By dehydration of alcohols. Alcohols are dehydrated to ethers in presence of concentrated sulfuric acid at 413 Kelvin. The reaction involves the removal of one molecule of water from 2 moles of alcohols. The synthesis of ether is a nucleophilic bimolecular reaction as given below. This method is suitable to prepare ethers having primary groups only. Dehydration of secondary and tertiary alcohols to give corresponding ethers is unsuccessful. Williamson synthesis. When alkyl halide reacts with sodium alkoxide, ethers are formed. Bromomethane is mixed in sodium phenate and it gives methoxybenzene and sodium bromide. Phenols can also be converted into ethers as given below. On mixing sodium hydroxide into phenol, it forms sodium phenoxide. Then, on adding chloromethane, it forms anisole and sodium chloride. Physical properties. Lower members such as dimethyl ether and diethyl ether are gases, while higher members are colorless, pleasurable smelling, low boiling volatile liquids. The solubility of ethers is comparable to those of corresponding alcohols. The solubility of ethers is due to the capability of oxygen molecules to form hydrogen bond with water molecules. The boiling points of ethers are much lower than that of alcohols due to lack of hydrogen bonding. Lower ethers act as anesthetics. Ethers are polar molecules and have definite dipole moments. Chemical reactions. Cleavage of CO bond in ethers. Ethers can be cleaved by using hydroiodic acid or hydrobromic acid to give alkyl halide and alcohol. hydroiodic acid reacts with diethyl ether and it forms ethanol and ethyl iodide. With excess of hydroiodic acid, alcohol formed further reacts to form ethyl iodide. Overall reaction is hydroiodic acid reacts with diethyl ether at 373 Kelvin and it forms ethyl iodide and water. The order of reactivity of halogen acids is in the order hydrogen iodide followed by hydrogen bromide and then hydrogen chloride. Mechanism of cleavage by HI. The various steps involved are dissociation of HI, protonation of ether, nucleophilic attack by iodide ion on the protonated ether resulting in the formation of alcohol and alkyl halide. The alkyl oxygen bond in alkyl aryl ethers can be cleaved by hydrogen halides to form phenol and alkyl halides. Electrophilic substitution. The alkoxy group attached to aromatic ring activates the ring towards electrophilic substitution and directs the incoming electrophile to ortho and para positions. Halogenation. Phenyl alkyl ethers undergo halogenation in the benzene ring. Thus, anisole exhibit bromination with bromine in acetic acid even in the presence of iron 3-bromide catalyst. Para isomer is obtained in 90% yield. Friedel-Crafts reaction. Both alkyl and acyl groups are introduced at ortho and para positions by reaction with alkyl halide, that is Friedel-Crafts alkylation, and acyl halide, that is Friedel-Crafts acylation in the presence of a Lewis acid catalyst like anhydrous aluminium chloride. Methyl chloride reacts with anisole in the presence of anhydrous aluminium chloride and carbon disulfide and forms 2-methoxytoluene and paramethoxytoluene. Acetyl chloride reacts with anisole in the presence of anhydrous aluminium chloride and forms 2-methoxyacetophenone and 4-methoxyacetophenone. Nitration. The reaction of anisole with a mixture of concentrated sulfuric acid and concentrated nitric acid forms a mixture of ortho and para-nitroanisole. Did you know? Ethers can be used as external cleansing agent, used as a solvent, and in the extraction of oils, fats, waxes, resins, and alkaloids. Methanol is also a high-octane, clean-burning fuel that is a potentially important substitute for gasoline in automotive vehicles. Summary. Let us summarize what we have learned. Alcohols and phenols react with lithium, sodium, potassium, and other active metals to liberate hydrogen and form metal alkoxides. The acidic character of alcohols is due to the presence of polar nature of OH bond. Phenols are stronger acid than alcohols. Alcohol reacts with carboxylic acid, acid chlorides, and acid anhydrides to form esters. Phenol reacts with acid chlorides and acid anhydrides to form esters. Alcohols, when treated with halogen acids, get converted into halolcanes. When alcohols are heated with acids like sulfuric acid, phosphoric acid, or boric acid, they get dehydrated. Phenols react with halogens in the presence of less polar solvents like carbon disulfide, chloroform, and carbon tetrachloride to give ortho and para isomers of monohalophenols. Salicylic acid is used to prepare aspirin. Most of the methanol is synthesized by a catalytic reaction of carbon monoxide with hydrogen. Ethanol is obtained commercially by fermentation of molasses, which contains sucrose. Alcohols are dehydrated to ethers in presence of concentrated sulfuric acid at 413 Kelvin. Ethers can be cleaved by using hydroiodic acid or hydrobromic acid to give alkyl halide and alcohol.